We are still continuing with detergents, and we need to look at the pollution effect of soapy detergents. What do they do to the environment that we stay in, or to the environment of these aquatic animals? So we have seen that these detergents, they lowers the what? The oxygen level hmm, in water, and this would result into the aquatic animals themselves being killed by this process, because when oxygen level is not that much in water, you see this organism, the environment is not going to have that much oxygen, and this organism will not survive, or else it will force them to move away. So therefore, when you're using these soapy detergents, don't go and use them uh, in the water bodies. Don't pour them in the water bodies. At least wash from somewhere. Fetch your water and go and wash from somewhere. Why? Because we have seen this thing can happen, and that means even if the fish in the water they will be affected. So let's go to water hardness. Water hardness. So when they say the water is hard, it's not that when you try to punch this, you will feel the pain. But when we say water is hard in chemistry, it means that this water has salts, dissolved ions in it. And you have ever moved in some places and you see that when you drink water, that water is salty. And when you drink water in another place, you will see that that water itself, it is not salty, and the taste is somehow like sweet, what. But just the taste of the color is that water is tasteless. So what we are meaning here is that if I have these ions, calcium ions and magnesium ions dissolving in water, then we shall get the hardness of water. But now this happen also in presence of these other ions, but we are picking this one because these other ions, they are soluble in water. Now let's say it from this, we see that there are two types of hardness. We have temporary and permanent, or synthetic hardness. So here the temporary one is caused by dissolved calcium hydrogen carbonate. So when they say calcium hydrogen carbonate, this is your calcium. I'm going to take you back to senior 2 chemistry. That's your calcium ions. Then when we say hydrogen carbonate, we shall have something of this kind, hydrogen carbonate. So after us having this, we combine the two, shall be in position to get something of this kind. And this balance will be shared by all these other atoms in the bracket. Now, when you look at this thing critically, it is these ions alone which is going to react with the ions in soap to bring for us what we call the scam. So here when you go back and read your chemistry, you will see how best you can solve the temporal hardness and this permanent hardness. We shall see how best we can solve them when you check those notes. Then here also, if it is not calcium, then that means this one can be replaced by magnesiums. So these are the first, this one, they are among the first 20 elements. This one here, number 20, then we have magnesium to be number 12. So these ions, they are not like soluble when it comes to this reaction. So hot water forms a scum. So this scum is that white thing you see when you're washing your clothes. If the water is salty and you're washing, you see something white like this, especially black trousers or black clothes. So that's what we call the scum. And this one is formed as a result of dissolved calcium or magnesium compounds. And the scum forms precipitate when this and this react with salt. So that scum, you will now see that precipitates those white things. That's what we're saying. In the example given, we shall write the equations and see how this reaction is taking place. Okay, if I have something of this kind, this is calcium ions. It is found in that water, which you say the hot water, which is aqueous, combined with, I'm just writing the ionic equation. We react it with soap itself, which is C17H35CO negative. So that means I've discarded the hydrogen carbonate ions and the sodium ions which are supposed to be here. So we are writing this one ionical. So this is aqueous. When this one combined, what is called a scum is being formed. So here we shall have something of this kind. Let me put like that. So this is now solid. This is the scum we talk about, the white thing you see when you're washing. And this thing can be balanced by putting two here. The charges are balancing and the atoms are balancing. So this is the scum we're talking about. If you tried it ionically, that is the equation. Now, what if, okay, if you are following enough, that means here we are dealing with a soap made from fat. How about we go and write that one? Made from what? Ions. And also, let's change the ions to, here we shall have what we call the magnesium ions, which is aqueous, combined with soap now. These ions in soap, we shall have 17. Here we shall have 33, which is oil, the vegetable oil. Then here we shall have something of this kind. This also aqueous. Also now they are in solution. You're washing, so at the end of the day you see something of this kind. The scum which is written like this. Put 2 here. Put them missing. So you put 2 to balance the charges. So this is what we call the scum again. That white precipitate you see. So we call the scum. So this is the all about the hardness in water. So there's that permanent hardness and temporary hardness. So the difference is that for permanent hardness, you have seen something to do with sulfate ions. So after you see sulfate ions like this, combining with this and this to form calcium sulfate, so that means that one there, you're dealing with hard water. I mean permanent hardness. So if it is temporary hardness, you get these ions.